What is up, beautiful people? Alright, so I am in Microsoft Flight Simulator in the Hype Performance Group H145, obviously, here in beautiful Huntsville, Alabama. Alright, wow, yeah, not even a sucker hole to be found. But that's alright, because we are not actually planning on, well, I'm going to do a little bit of flying eventually, but as of right now, we are going to be talking about symbology and systems. So the first thing I need to do is pull this guy out right here. We're going to go to this, and we're going to hook up external power. And now we are going to cruise up here and go on and engage. All right, and I'm going to go ahead and come in on this because this is primarily what we are going to be talking about. All right, so right here. So the first thing we need to talk about is a multifunction display. All right. Multifunctional display in these aircraft is a very, very complex thing in real life. The MFDs are full-blown computers, all right? So they have their own dual CPUs, they have their dual GPUs, and GPUs are called SnowRunner 1 and SnowRunner 2, which I think is an absolute hilarious name. Like to meet whoever made that and ask them what, or at least named it, and ask them what in the world they were thinking, all right? So each MFD can be controlled by brightness right here. The way I do it is I just hold my mouse over it and I roll up and down, so I can control the brightness on it. Now, this doesn't actually do anything that I can tell, and this doesn't actually do anything that I can tell. But all three of these together are how you can handle kind of your brightness, your contrast, all that good stuff on this. All right. There are three of these MFDs. We have MFD1, MFD2, and MFD4. Now, if some of y'all are feeling like maybe we skipped a number, that's because the system was designed to have 4 MFDs. When I say the system, I'm talking about Helionics. So Helionics is not just for the H145. Helionics is proprietary to Airbus and used in a whole host of their aircraft. And it's designed to have 4, being number 1, number 2, number 3, which is missing, and number 4. So that's why we have 1, 2, and 4 in this aircraft. We call them multifunctional displays because they can be any of the displays. They can be a flight navigation display, they can be a navigation display, they can be the vehicle management display, they can be a DMAP, they can be the miscellaneous display. So any of that stuff is available on any of the screens. You'll notice right up here it's not available on this screen. In real life, we would have to power down MFD4, and that would provide all of that functionality on MFD2. So the main parts of the MFD are, of course, the master on-off switch. You got the 6 master select keys selecting the main mode. So these are master select, line select keys in general, but the ones across the top are called master select keys. Then we have line select left, line select right, and bottom select. All right, and we number these 1, 2, 3, 4, 5, 6. Left select 1, 2, 3, 4, 5, 6. Right select 1, 2, 3, 4, 5, 6, and bottom select. Well, you get the idea. With that, we have the dual rotary button push assembly. So dual rotary because we have the outer knob, the inner knob, and we can click it. We can push it in, which in the simulation is a right click of the mouse. We'll do that for you. All right. So you'll notice not all keys are active. Here we have this is active and now it's not. Down here, neither of these are active right now. All right. So it depends on what screen you have up and what mode it's in and what flight parameters, and there's all kinds of information available. But basically, the magic of this screen is that it changes to meet your needs. So the flight navigation display format, which is what is shown right here. It displays, for your primary information, I am going to go left to right, top to bottom on this. We're going to start out right up here with the triple tach. All right, so triple tach consists of 3 individual tachometers, okay? So we have our NR, our nominal rotor speed, which is actually this pointer right here. That is backed up by this digital number right here, which gives us a percentage of nominal rotor. 100% is 383 revolutions per minute of the main rotor system. All right, so this tells us what percentage of 383 the rotor system is spinning at. Then our N2 for each engine is converted to percentage as well, and these are mechanically linked with a Sprag clutch. All right, so if this starts turning faster than these, the Sprag clutch will disengage and allow the rotor system to continue turning at a higher speed than the engines. However, if under any circumstance either of these 2 arrows, so you have an outer one and an inner one, if either of these 2 arrows spin faster than this guy right here, that means that you've got a high-speed shaft failure. And usually that thing's going to fling off to the side, it's going to high side, and immediately shut that engine down because it's going to reach its, I think 124% or 140. I don't know. I can make something up, but I don't remember right offhand. But if this N2 gets up to a certain amount, the engine will automatically shut itself down to protect the engine. It's already identified. It's basically figured out that it's not pulling any weight. It's not helping out at all, and it's going to tear itself apart. All right. So this inner one, the arrow, is your number 1 engine. The outer one is your number 2 engine. All right. This is your absolute minimum transient, the low end of your minimum transient rotor speed. All right, and transient rotor speed right inside of here is not defined anywhere that I've ever seen as to why they give you that big of an arc for the transient rotor speed. but you can operate down in this area without too much trouble. So this right here should be about 96.5 if I had to guess, because 96.5 is the low end of your normal operating range. 95.4 is right about here where your low rotor light is going to come on. And right in here is where that high rotor is going to start screaming at you. So you're going to get some beep, beep, beeps. And then when you get here, it turns into a solid tone that cannot be acknowledged. You can't get rid of it. All right, so this is the absolute max the rotor is allowed to be. This is your kind of like a max, a power off transient range. This is a power on transient range. This is a power off transient range. So if you're auto rotating and you end up in here, it's not the end of the world, but you need to get it back below this red line. If you get above this in an auto rotation, now you got some maintenance you got to do. All right. This scale right here goes from 80% to 120. The rest of this down here, which you actually see here, is gone from up here because this is your flight display. The idea is you're only using this in flight. This is used for startup and shutdown. All right, because it's part of your vehicle management. We'll get to the vehicle management system here in a second. All right, so left, right, top, bottom. Next thing we're going to come to is the AFCS tape. And we'll get a little more into that when we get into flight. But basically, this gives you information about your auto flight systems in the collective axis, the roll axis, and the pitch axis. So this can tell you anything from systems being disarmed, disabled, inoperative, degraded, armed, or captured and active. So red means the system is completely off. Yellow means the system is degraded. Cyan or blue means the system is armed. And then green means the system is captured and active on that specific axis. And whatever's inside of this box will tell you what has been activated inside of that. All right. So moving on, we got our clock up here. So we're going to hit the line select key, which is going to bring up our chronometer. All right. So our chronometer is just used as a timer. So we're going to come down here and we're going to right click this button, and that's going to start our timer. We're going to let it go for a few seconds. We're going to right click it again, and that's going to pause our timer. If we right click it again, it's going to start from where we paused it. If I click it and hold it down while it's running, it's going to start over, but it's going to keep counting. If I pause it and then right click and hold it, it's going to go back to 0 and it's going to stop. Okay? And then the other thing that we have here is our actual time with our UTC offset. All right, so right now where I'm at, it is 12:45. In UTC time, we can add this to it in 17:45. All right. Right down here is our synthetic vision system flag, and it is offline right now because I do not have my number one Garmin up. You gotta have both Garmin's up, and they gotta have a signal, and there's all a few other parameters. All right, so coming on down, we're gonna come down to this tape right here. This is your first limit indicator as well as your collective position indicator. So CLP and FLI. So right now it is the collective position indicator, and the only thing you're going to see on this is this rotor's desynchronization line. This is telling you that if I lower the collective below this line, I should enter in auto-rotational state. If I'm above this line, the driving range is larger than the driven range of the rotor disc, and I will not be in an auto-rotation. So being a low inertia rotor system, if you find yourself in a situation where you must enter an auto rotation, it can get away from you very quickly. And in the older version, the C2 version of this aircraft, which had the same rotor system, when you entered an auto rotation, you had to be Johnny on the spot in order to get into an auto rotation without drooping the rotor system in the event of a dual engine failure. But at the same time, you really had to pay attention because when you drop that collective, that rotor would go through the roof really fast. So you had to catch it. So this, now you're flying along and you just bring it down to 2.5 FLI, a little bit below it until the rotor starts rising, and then you know you got to stay right along in here. Okay. Another thing that it will give you is if you have a low rotor condition, this FLI will give you chevrons pointing down, telling you you need to lower your collective to get the rotor speed back up. Alternately, if you get all the way down here in an auto rotation and that rotor gets up here into this transient range, the chevrons are going to start pointing the other way, telling you you need to raise your collective to slow down the rotor because it is getting way too fast. All right, so there's a few more indications on this FLI that you will not see until we get in flight. So we're going to move on over here, and this is your indicated airspeed tape. All right, so at the bottom of this right now, it's telling me V vertical, my takeoff speed, VX, is 45 knots. That is your maximum rate of climb per distance X across the ground. The other value to be aware of that's similar to this is VY. That's your maximum climb rate. That's the fastest rate of climb that you're going to get because it's the most efficient speed for the rotor system. All right, so the next thing we get into right here is your attitude indicator. So this tells you your pitch and your roll. So this will line up with either of these right here, 15, 30, 45, 60, and it will tell you your bank angle. This dot right here will come along this, and it will tell you your pitch angle of the actual aircraft as you're flying along. And then also if you get into an unusual attitude, so you end up 45, 50 degrees nose down, and the aircraft will realize, hey, you are way not where you're supposed to be. And again, you will get those chevrons pointing which way the nose needs to go in order to get you back into a normal flight profile. Right here, you have your turn and slip indicator, or your turn coordination, your bank and slip, your skid. There's all kinds of different names for it, but basically this tells you whether the aircraft is flying in trim. If it slides off to the right, that means you need right pedal. If it slides off to the left, that means you need left pedal to keep the aircraft in trim so that you fly straight through the air instead of skidding sideways through the air. Right down here, we've got this yellow diamond. That is your GPS calculated instantaneous angle of climb or descent, so your flight path angle. So you could actually use this in the synthetic environment and place this diamond above an obstacle that you want to clear, and as long as that diamond stays above that obstacle in the synthetic vision environment, you will stay above it. Alternately, if in your synthetic vision environment you have a place that you would like to land to, or at least shoot an approach to, if you set your aircraft up to where this diamond is on that item, it will actually, and you leave it there, that's where the aircraft will arrive at when it meets the ground. So right here is your VSI, your vertical speed indication. All right, so this line will move up and down and point to 500, 1000, 1500, 2000, and then the scale will max out at 2400 up here at the top. And then that's rate of climb and rate of descent. Now, with your autopilots, you'll have bugs that you put in here, and so that if you activate the indicated airspeed, that bug will show up on this tape. If you activate vertical speed mode, that bug will show up on this tape. If you activate flight path angle mode, that bug will show up as a green diamond along this scale, and then the aircraft will climb or descend to put this diamond inside of that green diamond. All right, this is your actual altitude right here. All right, each of these are 20, and each of these are 100. So this tells you right now that we're sitting at about 650 feet, assuming that my altimeter is right, which I almost guarantee it is not. But for the purpose of showing, now that right there, that tape, again, if we set a autopilot bug on that T, you'll see that processing. Now, we'll take a second here to talk about colors on the autopilot. So this color right here, this brownish color, is a GPS ground speed, a GPS calculated ground speed. So anything that's got this brown color is a GPS-based calculation. If it's in cyan, that means that you have input that item, but it is not yet engaged. So you have preloaded that value, kind of like if I come over here to indicated airspeed, you see that cyan dot. I have not armed it, but I'm putting something in. Now notice if I go off the scale up here, it will then tell me the actual value of the indicated airspeed that I'm wanting to put in there. Same thing with my altitude. Now that altitude is up there above the tape, letting me know that that bug is off the scale. Same thing for your vertical speed. Right there, that vertical speed, whoop, I'm zooming in, I didn't mean to there. That vertical speed is coming up, and now it's going to be showing right up there. Again, it's in cyan, which means it is not armed, it's just preloaded. We have not activated it. All right, and then the last thing right here is your radar altimeter. That is the radar bouncing a signal off of the ground. And actually, right here, these are your radar altimeters. So it sends a signal, bounces it off the ground, and reads the signal coming back. And it figures out, so it basically sends a wave form down to the ground and then measures the phase shift of that waveform as it gets back here. And the further shifted that waveform is, the higher up the aircraft is. All right, so over here we have our settings for these three things down here. Our decision altitude is based on a barometric altitude, and that's basically, we're telling the system that when I am descending, as I pass through 900 feet, I have a decision that I need to make. But I may have a lot of things going on, so I may not necessarily catch when I cross that 900 feet. So by putting in a decision altitude, I'm telling the aircraft, I need you to tell me when I cross 900 feet, and it will say decision altitude, and this little flag will show up, and it will let me know that I am below 900 feet, and I was supposed to have made a decision, some type of decision. All right, this is based on a barometric altitude. Now, decision height is height above the ground. So that is going to provide that same functionality by using the radar altimeter. I'm telling it at 100 feet above ground level, I need to make a decision. So I need you to remind me when I am 100 feet above ground level. And the last thing is your barometric, your actual barometric pressure. So you're going to select Baro, and same thing, you're going to roll this, and that's how you put in your Baro. All right, a right click on it is going to bring it back to standard. Now, in real life, you would be able to, you could go standard and then adjust. In this, you cannot. So you have to click it again, and then you can adjust. All right, I don't know that yet. These don't perform any button press function. Actually, it looked like, so that one will get rid of your that button press will get rid of your decision altitude, but it will not get rid of your decision height. So, all right, down here we have our mast moment. This basically, because this is a rigid rotor system, as we try to tilt the disc does not tilt. It's a rigid rotor system. So the rotor system cannot articulate like other helicopters. So it bends the mast ever so slightly. All right, and actually the main bearing inside of the mast that seats the mast inside the transmission has a spherical type, almost like a ball bearing to it, or like a spherical bearing to it that allows the bending of that mast to be absorbed by that bearing. And this right here lets you know how much you are bending it. So this is a transient zone right inside of here that when you get into this zone, you have to keep track of how much bending has occurred. And you have to keep track of it on the mast log card and each of the blades and transmit. There's all kinds of stuff that you have to enter that in, and then certain components have to be inspected after a certain amount of mast moment, and even at a certain point are retired from service after they have experienced a certain amount of mast moment. And that red is basically you get above that, and now you're really into a situation where really doesn't matter how much you put on it, that you're losing it. Like there's stuff to be done. All right, HTAWS fail lets me know that my helicopter terrain avoidance and warning system is offline. So the terrain avoidance system will actually take over the aircraft and attempt to avoid terrain. Autopilot fly up is what you'll see. And then the warning system lets you know when you get too close to the ground or your rate of closure with the ground is unfavorable, or level flight will result in you impacting with rising terrain. You can also get into if you are in a takeoff mode and the aircraft knows that you're trying to take off and climb out, and the aircraft starts to settle back during takeoff, it'll start saying sink rate, sink rate, sink rate. All right, so that aircraft system is all part of HTAWS. So this is telling you that HTAWS is not working. And then ACAS is your I can't remember what ACAS stands for. Absolute just brain fart right now. But that lets you know when you're about to smack another plane. And it's very smart about how it does it. It actually can calculate whether or not another plane in your vicinity is a threat to you or not. So you may have one close to you, but you're on a divergent instead of convergent path. And so the aircraft is smart enough to know that it is no longer a threat. It's not a problem. All right, this is your horizontal situation indicator, your HSI, and this is the navigation portion of the display. This is the flight portion of the display. This is the navigation portion. So this is your horizontal situation indicator, and you have 3 different displays that can be placed here by this button right here. So this tape will tell you what the next in the queue is. So sector mode, hover mode, HSI mode. So that HSI just lets you know which way you are facing. And then your CDI, your course deviation indicator, will be populated on that to let you. And actually, I'll tell you what, let's just do nearest airport. HSV frequencies, we will grab that and pull it down. Let's just bring an ILS in, and boom, there we go. Now we have a course deviation to the ILS. We are not in line with the localizer of the ILS. All right. Now, on top of that, we can place additional information. So we can either do the ILS or whatever nav is in here. So if it's a VOR, it'll show VOR there. Right now, we have an ILS up in there. So if I click it again, this is the flight management system. If I were to go back and I were to have a direct enter, now that FMS would show, and now this is pointing towards where that was put in. All right, so this is going to point towards the actual ILS station, and this points towards the course that it pulls in. So it knows that that ILS is a 185 heading, and so it points towards the 185 and tells you you need to be flying a 185, but you need to slide right to get on course. This points directly at it. So using these two, you know you need to fly in this direction, otherwise you're never going to intercept this before you get to it. If you're in between these two, then you will not intercept that localizer before you actually get to the ILS station. All right, and then here's your FMS. This is going to point towards that right there. All right, and now if I change over my nav source, now my nav source is pointing that exact way. It's telling me that I am set to navigate towards that, which is in line with this. All right, so we talked about that. What we didn't talk about was course. So I'm going to come over here. I'm going to select a VOR. We're going to go to the rocket VOR once it pulls up. All right. We're going to put 112 in. We're going to hit it. And now I'm going to change this over to VOR. Now this points directly to the VOR. I'm going to change my nav source to the VOR. And now I have this course right here. I can select this, and I can set my course. I can set exactly what course I want to approach that VOR station at. So if I set my course to the actual radial that I'm on, I'm obviously on course. If I shift that course away from the radial, now I'm telling it I want to approach this at a different angle. So if I say I want to approach, I want to approach that VOR station at due east, then it's telling me, okay, you need to fly northerly to intercept that radial. Now again, if you have both of these up, the difference between this and this will tell you that if you want to intercept this radial before you get to this VOR station, you best be approaching this line from the left of this. If you are in between here and here, then you're going to blow right by that station before you ever intercept this radial. So this solid one is for system 1, and this one is for system 2. So actually I'm on ILS. So we're going to go airport, HSV frequencies. We're going to come down, and we are going to do an ILS. I'm going to drop that in there. And now, all right, so let's get rid of this. So for the purpose of showing you this, I am going to remove that. No, I said thank you. I said remove. And I'll remove that. All right, so now the FMS does not have anything in it, so now we're back to white on this. So these values right here are simply things that I have pointed. So I'm going to put this to the ILS coming from 1. So the ILS to Huntsville is on 1. The VOR from there right here is on number 2. So you can have both of these up at the same time. So you can tune 2 different VOR stations and do the whole intersection thing when the 2 stations cross at a certain point. Then you know where you're at. You can also use it. So let's go 112.20. We're going to transfer that in. Now we'll see 1 and 2 are both pointing to the same VOR. So we can verify that our VOR is good. We do our 28-day VOR check using this method. We would just have to go in and we would say VOR1, VOR2. They both point to the same spot. VOR check is good. We're at a 0.32 at 11.5 miles. VOR check good. All right. So coming on down and along, we have our ML, our master list, which is going to give us warnings in red, which tells us that immediate action must be taken to prevent an aircraft mishap. Cautions, which means that in the near future, you must take action to prevent an aircraft mishap. Then we have green down here, which are advisories. That's just letting us know that a test has been performed satisfactorily, or a system is online, an optional equipment system is online, like hoist, or we've got our IBFs open, stuff like that. And then white is a notification, which is going to tell us things like the air conditioner's online, or one of the things that it will tell us is trend. It will, if we have any type of redundancy that fails, but it's only a redundancy and it really doesn't matter, then that will be in white to let us know that, hey, just so you know, I took care of it. There's a backup system in place and we're good to go, but one of the systems isn't quite working properly. So talk to the mechanic when you get back on the ground. And then lastly, there's the trend, shows up in white as well. So say you're flying along and your hydraulic pressure starts slowly dropping. But of course, we don't fly with this system up because we don't need to see it. The computer's going to tell us if there's anything on this screen that we need to know about once we're in flight. So we're flying along and the hydraulic pressure is starting to drop. But we don't have this system up, so we can't see it. This system right here is going to say hide 1 trend. And when we see hide 1 trend, we're going to go, VMS, by golly, yeah, look at that, it's going down. We need to find a place to land because we're getting ready to lose hydraulic pressure in system 1. All right, over here we have the Hillary pantsuit, is what we call it. Once you see it, you can't unsee it. So that is your fuel, and that is all of your fuel. And these 2 little red lines are letting you know that you have fuel in the main tanks that is not being transferred into the supply tanks and is not going to be available to you. So if I come up here and I turn my transfers on, now they both turn off. Versus if I turn them back off, they come back on. Now you saw that yellow, I'll let them, and they'll come back off. All right, you see that yellow box around here that starts to flash. That lets you know that there is an active caution that has not been acknowledged. If it's red, that means there's an active warning that has not been acknowledged. All right, so before I close out this FND, I want to just sweep back over a couple things that I missed as we were going through. What I did not talk about was this guy right here, and I said I was going to come back to it after this, and I did not. This is the digital value of your height above ground. So right now it should say 0. It's saying 1, which is a negligible difference, but whatever. The other thing I did not talk about is your wind indicator. So if it's a circle, that means winds are slack right now. Winds are coming from the left side of the helicopter, slightly quartering to the tail, and about 10 knots, because we have a long barb there. A short barb is for 5, right? And then a little triangle on it, looking thing like a filled-in triangle, is for 50. So that'll give us a wind direction and a wind speed. The other thing so that's pretty much it, I think, for the MFD over here. I think we've hit everything. And now we're going to jump over here and start talking about the Vehicle Management System, the VMS. All right, so that is accessed by this Master Select 3 up here at the top. And then we'll just do the same thing here. We will go left to right, top to bottom. So the first thing we have up here is the bleed valves. All right, so these bleed valves are letting you know that the bleed valves are open and that the compressor in each engine, so this is for engine 1, this is for engine 2, the compressors for the engine are discharging some of the air to the atmosphere instead of sending it all the way back through to the fire and out the back of the aircraft. Basically, the aircraft has determined that the engines are nowhere near needing the maximum amount of power they can produce, so it is venting some of the compressor air overboard so that it doesn't blow the fire out, or we don't get surges or compressor stalls and all that stuff. All right, these values right here are going to be your old steam gauges, self-explanatory. Torque, TOT, and N1. It's your main 3 that you're going to use to determine, to keep your aircraft within parameters. This is all for the left-hand engine, and this is all for the right-hand engine. Now you'll notice we do not have an N2 indication there. The only way to get to that is on the VMS triple tack down here. These are your N2 indications for each engine. All right, so IBF is inlet barrier filter. So this is telling you that you have 1% clogging on the inlet barrier filter. And when that gets up to a certain percentage, at 40%, it will latch, and then you'll get a clog trend. And then at 60%, 65%, something like that, it's recommended that if you're going to do any type of dust landings or anything like that, that you fix it. And then when it gets to like 100%, you're required to clean the filters before you send it. And it's basically a giant K&N filter. You just spray stuff on it, a degreaser, spray water on it, clean it out, let it dry, blow air through it, all that good stuff, and then put K&N filter oil on it, basically. All right, down here are your temperatures and pressures. So hydraulic, system 1 and 2, engine 1, engine 2, temperature and pressure, and then main gearbox right here, temperature for the entire system, and then oil pressure in system 1 and system 2. All right. Continuing on down, we have our fuel right here. This is our main tanks. The aircraft has a main tank and an aft main tank, and both the main tank and the aft main tank are together in this right here. This is your left supply tank. This is your right supply tank. The left supply tank has less capacity than the right, so that if for whatever reason you fly it all the way until you flame this thing out, the number 1 engine will flame out before the number 2 engine does. It'll buy you about 10 minutes of single engine time to be able to get to the ground. And there's all kinds of warnings that you get before you get to that point, so I really don't understand how in the world somebody would flame this aircraft out and not realize that they were running out of fuel, but it has happened, so very strange. Generator 1, so this is your electrical state section. Generator 1, generator 2. Generator 1 is offline, so it's in white. Generator 2 is offline, it's in white. It can be green if it's online and operating normally. It can be yellow if it is producing an overvoltage or an overcurrent, and then it can be red if that overvoltage or overcurrent is beyond a certain limit. All right, this right here actually should not be showing because I have not hit the num, so this is not an over limit right now. The only time that you will see these numbers in the current state is if they're outside of their normal limits, and they'll be highlighted in a color. So these are highlighted in yellow, saying that it is under voltage, but this would not show like that because the aircraft knows, obviously, it's under voltage. It's not even online. The battery, the voltage is obviously within limits, so it's not showing that voltage. If I click number, it'll show me the voltage, but I am within limits, so it's not going to show it. The amperage that is being drawn does show, because it wants me to know anything over 0 is going to show, because it shows me that I am bat discharging, which is a 5 amp. Anytime you're more than 5 amp draw on the battery, you will get the bat discharging. All right, and then so right here, 0 amps on each generator, which is normal. All right, so this right here means that we are on battery power, the battery is connected. This right here means that we are on external power. You should not have both of these at the same time. There's an interlock that when you go on external power, it disconnects the battery from the aircraft. So you should not have both of these at the same time. You cannot charge the battery using external power. The only way to charge the batteries on the aircraft is via the generators with the engines running. So as soon as you plug this in, this should unilluminate. Deluminate. I don't even know how am I supposed to say that? It goes out. How about that? And then this right here would show that you are on external power. All right, come down here. This is your data section. This is where you would go to input your weights. Or this is your power and performance page right here. And I can switch that over by going data, and that's going to give me my time. This should be the same time as that right up there, and look at that, they match. Something to know is that this time is stored inside of the data transfer device, this thing right back here. And there's a keep live battery inside of there, so that when you power off the aircraft, it keeps the time. The first 34 seconds of the aircraft powering up, the AMCs, and specifically Aircraft Management Computer number 2, is pulling that time and comparing it with the time from this. And at about 34 seconds after power on, this should have gotten sufficient satellites and pulled a new fresh time, which loads it into the MFD2 and goes up there. So at first power up, this time right here is loaded into AMC2 and pushed forward to MFD2. And then after about 34 seconds, the time is updated in AMC2 via this and pushed to there. And then simultaneously, it updates the time inside of the data transfer device back there. And the data transfer device, just so you guys know, is responsible for arbitrating all of the communication between your MFDs and your AMCs down there in the belly. So this is a 16-port Ethernet switch, as well as an SD card recorder for engine data or aircraft data. All right, so come down here is the status. This is your FADEC system status. So the FADEC has its own ambient air pressure sensor. So this value should match this value. All right, your T1 is, this value should be reading the same pressure as the system that is producing this. Now we have to put this in so that it knows how to convert that pressure into a number, but the actual raw pressure that is being received by the system is the same. All right, T1 is on the engine intakes. Collective lever position is this guy right here. So it's basically saying that the FADECs are receiving this collective lever position from the aircraft, and then we just make sure that that matches that. And it looks like it does. All right, this is our N2, our actual N2 being reported by each of the engines. This N2 datum is the N2 that Helionics is sending back to the engine, saying this is where I want the rotor to be. All right, and then our current fuel temperature, based off of, so that the fuel flow meters are also temperature sensors, and that's where you're going to get this from. And then your mast moment. I'm not sure why the FADEC is concerned with the mast moment. Doesn't really make sense to me, but whatever. All right, and then this is your IESI, your Integrated Electronic Standby Instrument. This performs all the functions of, well, most of the functions of this right up here. So obviously does not, no collective lever position, no AFCS tape, no timer, no decision height, but your main ones right here are shown over here so that you're able to get a altitude, an airspeed, and then a aircraft attitude, and it has a separate barometric. So when you guys are setting your barometric pressure, really what you should be doing is you should go to this side, 299, let's go to 3002, 3002, 3002. And then we would say, all right, set left, right, and center. All right. This controls the brightness of it. This recages it and brings it, realigns it, and then this brings you back to a standard. That was interesting. It affected these. It should not do that. That is new. So it should not actually affect these guys over here. Interestingly, also, if we go over to the reconfiguration page, we'll notice right here that the IESI has its own pitch and roll sensors inside of it, fiber optic gyros. It also has its own air data inside of it. So air data computer 1 is pulling this information, indicated airspeed, and the ambient pressure, which we'll notice 1013 is the raw pressure, which matches 1013 being read by the FADEX. All right, which is also the same as being read by the air data computer inside of here. So the IESI has both of those. Now what the IESI does not have and does not have access to is this right here. And what this is showing right here is that air data 1 crosstalks with the IESI to make sure that air data 1 is accurate. And actually the IESI is talking to the AMCs. All right. That's pretty, you know what we did not talk about was the warning unit up here. So I am going to
audio test.
We'll kick it over to the lamp test so that you can see right here all this stuff. So low fuel 1, low fuel 2 is my warnings that I'm getting low fuel. Engine 1 and 2 fail. We'll match this. Rotor RPM is always going to show up, so nothing on this is ever actually suppressed. The items on this will be suppressed, but this is not. So we will get rotor RPM. Engine 1 and 2 fail. We have main gearbox oil pressure, but we do not have it there because it is suppressed here. Obviously, the engines are not running. The rotor's not turning. No wonder we don't have main gearbox oil pressure. But this light is directly from the tap, so it's going to illuminate anyway. Our autopilot has failed because it's off, obviously. Suppressed here, but it's back up. It's up there. We got our battery overheat. Now, the other things that we have here is we can tell it to discharge the fire extinguishers. All right, and we also have, this is our engine our fuel shut-off switch. All right, so if we had a fire, we would raise this, and we would push that, and there we go. Engine 1 fuel valve closed. So what that does is back here, VIP, you can't see it, in the wall where the main fuel comes up from the tanks, we have shut-off valves. When you push that button, it shuts it off. Now, we should not get any of this symbology right here because we do not have a fire. You can push this all you want, and it's not going to light up any of that unless the engine actually detects a fire. And here's the other thing is it doesn't appear that I can open that. Oh, there it goes. Okay. But these are not going away. So that's interesting. We'll do it to this side. It will. But, okay, there's... No, I cannot open those back up. So that is interesting. So that's a bug. That should not do that. It should not light this up. And you should be able to open it back up by pushing that button. So, no matter. All right, so coming back to this, let's go to data. And let's come down here to, we talked about status. Report doesn't really work. This is your flight report at the end of the flight. Tells you how much battery time, how much maintenance time, how much flight time. A KO time is another thing for block time. Same thing. It also lets you know how many cycles N1 and N2, and there's limitations on the engine. Components have to be replaced after a certain number of cycles. But there should be 4 pages on this flight report. This is your OEI time, so if you had to use up any of your one engine inoperative time, this would tell you at the end of the flight. Creep life damage is the computer calculates how much stretch on the turbine blades. And then lets you know. And then the 4th page is your total landing cycles. If you have more than 4 pages, that means you had engine chips or transmission chips or low pressure or there's 14 of them total. I don't remember what they all are. But I don't think this works because I don't remember seeing this. This should show up at the end of every flight automatically. All right. So configuration, you can't actually do anything with this. All right. But over here, if I add or remove equipment, it will show up. So I'm going to come down here and I am going to say, I'm going to take my inlet barrier filters off, and there you saw it update says not installed, and they dropped away there. Installed. So the way this actually works is normally you would physically remove the stuff from the aircraft, and then you would power up the aircraft. You would come in here, and you would tell it. You would click this and roll to it, and change it from installed to not installed, and then the system would know that that's no longer installed. All right. We do have flow sensors, so we'll go ahead and put those on. Boom. How about that? There they are. All right, and then the last thing on this is the weight. And so what we would do is I'm going to click here, and clicking that processes through. And I could say, let's say we got our 2 pilots, so 345 pounds sounds about right. Total fuel, let's go ahead and bring that up. And that is, yep, there's plenty of fuel right there. And then for our payload, let's go ahead and bring that up as well. I'm going to bring it up rather quickly until I'm going to go right just below that total, and I'm going to validate it, and then I'll go previous, and you'll see right there, this is telling me that I'm legal to take off. I can hover in ground effect with both engines operative, all engines operative, but I cannot hover out of ground effect. I will not have enough power. I will not be able to perform a Cat A vertical takeoff. I do not have OEI 2-minute or 30-second hover out of ground effect. So this is telling me right here that I will not be able to do this. If I come back to this and I bring it up a little bit further, now I have exceeded the aircraft total weight. So weight exceeded. You're just saying 8 yellow hovering ground. So by that going yellow, that automatically means that I cannot fly. So you would come in here and you would take weight out of the aircraft and validate it, and then come back, and now we are green, 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 fully legal to fly. All right, so the other thing is you'll notice that this triple tack down here looks a little bit different on this screen than it does up here. We have 80 to 0 down here, and there's an additional white arc there. That is your rotor brake arc. So as long as this is inside of this, you are safe to apply the rotor brake. And on coast down, as soon as it passes into this will fill in solid. So whereas it comes up a thin line here and then this will actually fill in solid white the whole way and let you know that you are in the safe range to apply the rotor brake. All right, so now we are fired up. We'll notice that some of our symbology has changed here. Now our cyclic position has now turned into a vectoral mast moment. And so now, instead of this sliding scale, we have this vectoral mast moment that will tell us if we get into a mast moment situation. So I'm going to go ahead and... but that would be how that is. Now, once we start flying, that goes away because mast moment really happens on the ground. You don't have to worry about it too much in flight. It is possible, so if you get anywhere near a range, it will show up. But for the most part, it's an on-the-ground type thing. All right, so we'll notice up here we have some more symbology. So this yellow range is our allowable transient range, and then we have a unallowable, we'll say, transient range in between this red bar and this red teardrop. The red teardrop is now going to tell us the absolute maximum that if we exceed that, we have officially exceeded something. If we're in this range, then we have a time limit before we officially exceed something. And this right here, we have a time limit, but it's much more permissive. All right, so I'm going to go ahead and then you'll also notice right now we have generator 1 and 2 online. They are both in green, and our battery is connected, so we should be charging the battery. And if I bring up the numbers, we'll see here we have 28.5 volts being produced by both generators. Realistically, this battery should also now be up at 28.5 volts because the generators are charging the battery at 28.5 volts. And then each generator is producing 12 amps, and there's negative 25 amps going to the battery. So there's 25 amps flowing back into the battery. And that number will continue to reduce throughout the flight until the battery is fully charged. All right, so... I'm going to go ahead and pick this thing up to a hover. We're going to talk about some more of the symbology that we see as it comes into view. So if you look on our collective lever position, holy cow, we are heavy. I tell you what, how about we're going to go to GTCH mode. And that is starting to cause a bit of a problem for me. When I go into GTCH mode and I let off the pedals, we are off to the races. So, yep, no matter what. Okay, well, I'll have to report that one. All right, so if we look right here, we have this blue line. That is our maximum single engine power. All right, so if I were to lose an engine, if I am below that blue line, then I will not be in my OEI 30-second range. All right, so let's bring this back online. And I tell you what, let's go ahead and let's add some weight. All right, so we're going to validate that. And now I'm going to pull up above that blue line, and I'm going to lose an engine. And now you will see that is not right. Look at that. I am losing. This should not. Absolutely should not happen. As I pull power, this N1 should be coming way up here through the roof. Torque should be all the way up where it's supposed to be. And that rotor should not be going down. So that is quite wrong. But in theory, as long as I'm below that blue line, then I will have plenty of single engine power. So the next thing, we are still having a hard time getting that rotor to come up. And I need to go ahead and bring that weight back down. That was weird. So definitely some weirdisms going on here. All right, so that yellow line right there is my MTOP, my maximum takeoff power range. There's another one. So I'm allowed 30 minutes in this range, and when I enter it, it goes solid yellow. I come out of it, it goes back. This right here is the top of my maximum takeoff power range, and this is the absolute max torque that I can pull. If I pull above this red line, I've got 6 seconds to get out of it. And it's going to start fussing at me. It fusses at me at 6 seconds. And then at 12 seconds, there should be some sort of indication. Now, these two do not match. Here I am in the yellow there, but I'm in the red there, so that's not right. And here I'm in the yellow, but I'm not in the yellow there. This is my first limit indication, telling me that I am the first thing to reach, that my collective position is causing me to approach a limit. And then if I go here, this should tell me, whichever of these is in yellow, should tell me which one I am limiting on. All right? And that torque range is supposed to be it. So that should match up. Now you'll notice, oh, that's supposed to go to GTC mode. So that's weird. All right, we're going to pick up a little bit of forward airspeed here. And we're going to notice that start moving. So as I pick up airspeed, that is going to get smaller and smaller. Now that should not actually start shrinking until I pass VY. So let's see what it does. Let's pick up a little more. All right, so yeah, right about VY it starts, and then VY plus 20 is where it's going to minimize to nothing. And look there, I'm in the yellow, but I am not in the yellow, so that is not right either. All right, so I'm going to bring on my SVS by pushing this button, which will bring up my synthetic vision. I'm going to lower that luminance so that I can actually see. And now we're going to look at this value right here. All right, so we'll see. I'm going to cancel that upper mode. All right, so right there, it all went black, letting me know that I'm in basic attitude, and then that will go away because this is a dead-faced indication. And there it goes. All right, so down here, actually, let's go right here. This is our current ground speed, which is less than our actual airspeed because I'm fighting a headwind. Now, if I turn this way, we'll notice my current ground track is going to start deviating off to the side because I will be flying through a crosswind. So we fly that to a crosswind. And now my airspeed pretty well matches my ground speed. Although my ground track seems to be deviating the wrong way. This should be over here somewhere. So let's make sure we get a good crosswind, and we'll slow it back a little bit to make it a little more pronounced. There it goes. Now it's showing that, and it's also showing that my airspeed is slightly, or that my ground speed is slightly above my airspeed. So I'm going to go ahead and I will turn and go this way. And now, as we turn into a tailwind, we're going to notice that ground speed start picking up well above the airspeed. So not quite 15. Well, yeah, actually, that's right about it. So that is perfect. And this is our flight path angle that we're climbing at. All right. If I lower my collective, you'll see that flight path angle start coming down. This right here shows me my deviation. Shows me this is where I'm actually headed to. So let's test that. Let's nose this thing over. And let's aim a little to the left here. And we're going to put that right on the corner of the river. And I'm not going to look outside the aircraft at all. We're going to leave it just like that. And we're waiting for our airspeed to stabilize, so we're not quite steady state right now. That appears to be steady state. All right, so I'm going to say, turn left a little here because we are slightly turning, and that looks to be about it right there. So we're just going to leave that alone. And we're going to see if that puts us on an approach to that point of the river. I'm going to bring it up a little bit. There we go. All right, so we're on a steady state approach. And this should put us right in the middle of that bend. You'll notice our tailwind started dying off, which changed our trajectory a little bit, but I'm still keeping it using collective only, right in the middle of that bend. And if we look out, that appears to be pretty much right where we are headed. All right, so that's the GPS value. And I tell you what, I'm just going to let this thing do all the way, and we're going to crash it, and we're going to see. But I tell you, it looks to be, boy, that's it right there. Kachuga.